So let's start about proportionality. I'll explain proportionality through an example. Now, in the physics, there's a very simple formula that many of the students of the physics will definitely read. This law, in fact, is called Ohm's law. The Ohm's law tells us a relationship about voltage across a electric conductor and the current passing through it. Let us suppose that there is an electric conductor, its two ends are A and B, and we have applied a voltage equals to V across its two ends. Now the current passing through it is I. So the Ohm's law states that this voltage across these two ends is directly proportional to the current that is passing through this electric conductor, or it is written as V equals to Ri. Here R is a proportionality constant and it is called resistance. Both V, R and I have different units, and V is said to have a directly proportional relationship with current I. Now, when I say that the two things are proportional to each other, it means say that if somehow say current is changing in certain way, then voltage V is also supposed to change in that certain way, such as it follows the formula V equals to Ri. The formula V equals to Ri shall always hold true, and if any change in I has been made, a corresponding change in voltage V shall change. Similarly, if certain change in V has taken place, then a certain corresponding change shall definitely come out in the current as well. Resistance R is a proportionally constant, so it has no effects on changing of current and voltage. So let's solve a problem in order to more easily understand proportionality. Now what I have done is that I have increased the voltage to double of the original across this electric conductor AB, and now I want to know that how its current has changed. How I'm going to do is that first, in the case 1, when V voltage was across its ends and the current I was going through this conductor, I'm going to write an equation equals to VO equals to RIO. VO means voltage old and IO means current old. R is the proportionality constant which remains fixed. In the second case, what I have done is that I have increased the voltage to double. I'm going to write this equation for this as Vn equals to Rin. Here Vn is nothing but the voltage nu and In is nothing but the current nu. So I know that the Vn equals to 2VO. The new voltage is double to that of the older voltage. So now I put the value of Vn equals to 2VO in this equation, and what I have is 2VO equals to Rin, or In equals to 2 times VO divided by R. Now from the first equation I have is that V by R equals to IO. So I put that V by R equals to IO in this equation, and I have In equals to 2IO. What has happened is that the current has also increased to double. See, that's what it is called, that the current and voltage are proportional to each other. The voltage increased to 2 times, the current also increased to 2 times. Now, this is another example. Now, we all know that the area of a circle is pi r square, where r is the radius. So, the formula is A equals to pi r square. This area A and radius r are proportionally attached to each other. How? Now, suppose that I have somehow increased the radius of this circle to 1.2 times of its original one. Now, I want to know what has happened to the area. Okay, so I just write the equations just I wrote in the earlier example, and I'm writing that AO equals to pi RO square. AO again means the older area, RO means the older radius. Now, the AN equals to pi RN square. Now I know that the Rn equals to 1.2 times RO. I put this value of Rn into this equation, and I have is AN equals to pi whole square of 1.2 R, or AN equals to 1.44 pi RO square. Pi RO square is nothing but AO. So what you have is AN equals to 1.44 AO. The area nu is 1.44 times of area old. So you see that how things changed this time. This time when you increase the radius by 1.2 times, area didn't increase 1.2 times, it instead increased 1.44 times. This thing you must keep very good in mind, that in the proportionality it is not simple that if you are doing certain quantity double, then this corresponding quantity that is proportional to it is also going to be double. How this another quantity which is proportional to it is going to change depends on how the two are related. So the formula you must always know when you are dealing with the proportionality questions. Now there is this another problem. Now in this problem, what is this? So we know that the formula of distance is given as average speed multiplied by time. Now there is a train, and this train is doing a journey and it covers certain distance d with a certain average speed and in certain amount of time. In the journey 2, its speed say has been doubled, while its time of the journey has been quadrupled. So what happens to the distance of the journey 2? We want to compare the distance of the journey 2 and the distance of the journey 1. So what I'm going to write is the equation for the first case, that the distance d equals to s multiplied by t. Okay, so this one is for the first case, simple. D equals to s multiplied by t. Now in the second case, d equals to s is now 2s and t is now 4t, because the speed was double and time of the journey was quadruple. So now the d comes out to be how much? Is 8 multiplied by s multiplied by t. S multiplied by t is nothing but the older d, so the d journey 2 has become 8 times that of journey 1. See, in this case was that this distance is directly proportional to the product of average speed and time. So that's how the proportionality questions are done.